Hi, my name is Gaston. It's the usual group, as always.
Yes.
So Ronnie.
Aurelia.
Me.
Jose.
Meg. Okay, so we're doing a little review session on the chapters 22 to 23. 26.
Yes. And we're gonna try and go over the concepts that we had in the review just so we can get more practice for the test tomorrow.
Okay. Take it away. Adam.
Okay, so to start us off, we're going to be talking about fossils. And first off, where are they found? They're found in sedimentary rock layers. So like whenever it's like a dinosaur died or something, it was like that was like the top ground at the time, but then more sediments and sands like piled on top of like their corpses, and then it just formed like various layers of rock. Yeah, and we can date them because there's like a distinction in like color between older layers and previous layers, and we can date them back into when.
I have something to add to Adam's stuff. I do recall that since so much of land now used to be underwater, like I think it was like Oklahoma, it's known for its like red rock. You could go around and people find several different fossils just lying around because apparently the whole state itself was underwater previously.
Well, I mean,
So
the entirety of all
Texas.
land.
well, no,
Yeah, all the land was underwater at one point.
didn't know that. You learn something new every day. Okay, Adam.
But yeah, and this tells us how life has changed over time. Like for example, Australia used to be connected to Antarctica, and it was like flourishing with like trees and
Vegetation.
other forms of vegetation like that. And it can tell us the traits of such animals and their gradual evolutionary changes.
Which that goes to me, which that really leads into like homology and like convergent evolution. Well, there's basically two types of evolution, which is convergent and I do believe divergent. Yeah, divergent. Basically, convergent basically means that they have the same structures as in cats, humans, and whales. Bats are the usual ones that we use for examples because they have the same bone structure. As in, they have like a humerus, radius, and ulna, which means this basically means that they had like a common ancestor back in the day, which led them to where they are now. But divergent evolution is basically how they have like a common trait, but they don't have a. It's
Divergent is when they have a common ancestor, but not necessarily a trait.
but yeah, trait. I was thinking about what's it called.
The convergent. You're thinking convergent.
Is that thinking convergent? No,
Yeah.
there's one that's like the bones. Yeah, convergent. That's what I was talking about.
You said divergent.
Oh, I meant to say convergent, where they have like a similar trait, but they don't have like the same ancestor. Which the example used in the book is like the dogs, which they have even-toed. Well, other like four bipedal, not bipedal. It's two legged, but like four-legged like animals have like a even-toed like paw or whatever. But like dogs, on the other hand, have only two, which is three. I don't know, but it's an uncommon amount, which shows that they aren't related with a common ancestor. And you can usually graph them with a evolutionary tree.
Yeah.
Which would bring us to
Which would bring
Meg.
us to Meg.
So the phenogenic trees, that's like it's how we place organisms and like show the relatedness through ancestry, and sometimes like through a lot of like disconnects as well. Even though they're not necessarily related by ancestor, they have common traits because so like the structure itself for these trees are like branching out. They're not necessarily about time, they're just about genetic closeness. So like you'll start out with a common ancestor, like one common ancestor, and you'll show all the branches coming out from that common ancestor with a binomial classification, specifically lineos? Is that what you
I
say?
think that's what you said.
Yeah, who like established the families to orders, orders to classes, classes to philia, philia to kingdoms, and kingdoms to domains. So basically going through and saying the genus and a specific description of it, which separates it into like clades, which is like the shared deprived characteristics. So like you have your monopenic, your polypenic, and your parapenic. I don't think I'm saying that right, but those are your different like classifications. Where like the mono is like where it's just like the ones from branching from a second common ancestor from the first common ancestor. And then the polypenic is just having like a trait that's passed along through different like some of the ones from a same common ancestor other than the first one, but then another one from a different common ancestor having also that trait. So yeah.
So that is me.
Yes.
Now we're going into natural selection. It can be broken down into a couple of different categories, I would say. Because while we do know that natural selection originally derived from Darwinistic ideals and thoughts, and survival of the fittest, whereas the fittest is like your reproductive rates, this can be broken down further into more specific categories. One of those is genetic drift, and this is mostly due to chance events that can occur that changes the allele frequencies in a population. So really it's not something that can be controlled because it is out of our hands, out of the hands of the species that it occurs to. The next is gene flow.
Can I pause? Yeah. What would be an example of that? Like an event for genetic drift?
Migration. Well, I guess migration could be.
What it would be like? An example would be like a road. Like if a road is built by humans, it like splits a population, or is that an example of something else?
That could work.
That could work.
Yeah, because it's
As
just
long
by
as it
chance.
shows, yeah.
Yeah.
It's not something that the species could do anything about, so it separated it. That could
It's
be.
separated, and then like they tend to like have different genetic variety on both sides.
Yep, that would be speciation.
Never mind.
What?
I was gonna say that. Wouldn't that be allocative speciation?
Yeah.
Yes,
Oh,
it's
okay.
actually
Yeah.
right.
Since our
I made it sound like that was surprised, but it wasn't. So yeah, what was I saying? I was saying, gene flow. Gene flow would be the next part of it. That's the genetics or genes that are going in and out of a population. I personally associate it with migration and immigration. Emigration, they sound the same, but one starts with an I, one starts with an E. So, species entering an environment and leaving it, or leaving a population, entering a population. And this changes the allele frequencies that are present in the population, which can later lead to a more of one trait or less of another. Excuse me. That leads us to mutations. This is, while it can start off small, mutations usually begin with one specific individual. And then, based off that specific individual's fitness, so whether they grow and go on to a reproductive age, or how many offspring this individual produces, dictates whether those mutations are passed on. If said mutations become considered desirable, then they could potentially prosper, and that would mean the survivability increases, so those organisms would continue to reproduce, and it might even become a signature trait in a specific species.
Wouldn't that be like how we have 5 fingers instead of 6?
Yes, it is more favorable, especially like said the thumb. The opposable thumb is something that sets us apart from a lot of organisms. The ability to grasp and hold things like cups and such. that a lot of organisms aren't able to. That's an adaptation, a mutation that happened, and because it's considered favorable, we continue to evolve with said trait. So thank you, that was good. And the next one that we're going to talk about is the founder effect. So this is typically when only a couple or a few individuals from a species or a larger population, this could be like the Galapagos Islands since they're fairly far apart, they leave the population or leave the larger group and start a new one in a different location. So they are considered founding a new population. So hence the name founder effect. And last but not least, the bottleneck effect. Okay, so since I think the name is super fitting, bottleneck, so it's narrow. When you pour stuff out, only a few survive, only a few come out of the bottle. And this kind of wipes out a lot of species. Usually occurs for some sort of catastrophic natural disaster. This could be earthquakes, tsunamis, volcanic eruptions.
Flash flood.
Yes, flash flooding. This is stuff that usually happens on islands, which is kind of unfortunate because islands seem to hold the most diverse life on Earth. It's really sad. But yeah, these large events will kill off a large portion of a population of some sort of species, and thus killing off a lot of the genes. You can end up with a lot of specific alleles here or a lot less here, and that dictates how the species evolves from then on.
Just imagine if like we were all like wiped out, and then all that was left were those people in that one island that walk on all fours.
Yeah, like several indigenous peoples would. That would be the new thing. Like they would walk. Humans would walk on all fours, and that.
I don't remember.
Yeah, I forget what it was, but it was some. It probably is one of the lesser known islands and such, but yeah, that is a good example. That would be really sad. That'd have to be crazy. But global warming, so
Global warming, we'll all die.
that may very well happen.
Yes.
Yay.
Global warming, we'll all die.
And I will now pass it on to Ryan.
All right, so I'm going to be covering the different types of selections that often occur within habitats in between species. And so to begin, I'm going to start with natural selection, the basis of the 3 different selections that we're going to go into. I went up a little early, but for natural selection to first occur, a population has to have a variety of different traits. That's the first thing. Second, these traits have to be inheritable so that they can be passed down from these different organisms. Third, there has to be variation within the favorable traits. This allows for, as Ronnie was saying, survival of the fittest and competition between the species. Fourth, more offspring has to be produced than those who survive to allow for the generations and for organisms to continue living on and not die off. And then last but not least, those that survive have the favorable traits, and this allows for natural selection. And so now with the different types of selections we're going to go into, oh my word, I'm trying to show it. You can't flip the camera again?
You can.
Stop it. Okay, so I tried to make a little graph. Okay, I'm not sure if it's going to be backwards, obviously. Okay, oh my word. Okay, so on the x-axis, you have your short, medium, and long. Okay, and this is basically going to show, stop it. Okay, so my first diagram that I'm going to show you is directional selection. And this is where conditions often favor an individual with one extreme type of phenotypic range, which leads to like a shift in the allele frequencies. And so an example of this could be if a lizard has a short tail and wants to scare off predators, it may adopt like a longer tail or so, through this selection, just so that it can scare off its predators, as it is one extreme type of trait. And so as you can see in this diagram, the black one, the marks with the dashes, and the original mark is in the middle, as you can see right there, and it's selection against one extreme trait. And so then you see the population after the selection at the very top. All right, and next I'm going to go into disruptive selection. This one's a bit more complex, as conditions favor individuals at both extremes of a phenotype. And so with this, an example may be that short tails keep a predator from catching animals on the ground, like a rabbit or so. And then you see that long tails are good for balance, and medium tails are not useful in either situations. And so therefore, for that reason, you see animals with short tails and long tails, because like we said, the short ones keep them from being caught on easier by their predators, and then the longer ones can help with balance. And so with this one, you can see in the middle, it's not being met there with the original. And then you can see the bumps in the short and the long, because the medium is useless within the disruptive selection. So you can see on the blue line, it's the population after selection is met. And yeah, this is just selection against the mean. So you have short, medium, and long. And then your original is just like in this area right here. And sorry, it's kind of hard to read. I'm very sorry. I wish I could flip my camera. I'll maybe write it in a mirror next time. I'm very sorry. But so last but not least, I'm going to go into stabilizing selection. And within this one, you can see that it favors intermediate phenotypes. So you may see that a short tail messes up a line's balance, and then a long tail is maybe too long to where it droops onto the ground and is useless. And so within this reason, medium tails would be the win-win. So as you can see, you have your normal curve, the black dashed line on the bottom. And in this little corner right here, you have the original population of lions. All right. And then after selection against both of the extremes, you can see the population after the stabilizing selection has occurred, meeting right in the middle, so that it's not at the short or the long extreme, but it's right in the middle at the very top. Okay, and then I'm just gonna zoom in. Okay, and then I'm just gonna stay right here for now while I explain this. Okay, and so you'll see mating between intersexual and intersexual. So with intersexual, you'll see that one sex completes, oh my gosh, I cannot read, directly formates, like, so within lines, you'd say the males are more dominant within the intrasexual mating. And then with intersexual, one sex, I feel.
It's like pickier. It gets to,
yeah.
It wants a specific trait. In this, a good example.
It's like flaunting, like the peacocks.
Yeah.
They're a little pickier. They like to compete a little bit.
Yeah, it tends to be the males who have the bigger flash.
It's like where like the males try to show off to the females.
Yeah.
Exactly.
And sometimes the showiness is like
annoying.
It's actually detrimental to like
Weird.
their survival. So it's like,
For like
the birds of paradise. I don't know.
who's got the prettiest colors,
Yeah, the birds
the
of
brightest
paradise
colors.
are like super isolated species.
Mhm.
So they've evolved into some weird. I don't know if y'all have seen them, but their necks will wrap around. They're super flashy. They're probably the epitome of flashy.
the ones
But,
that have like the
Those
faces.
are the ones exactly, and those are the ones who are able to find a mate, because the prettier you are, the more you attract.
That's how like traits are passed down, and that's how.
It's like being a girl in this age.
And pretty.
Having to be pretty.
If you're ugly, like sucks. Like
Lash extensions is
you're
Like, if you're me,
ugly,
no, I'm just kidding.
We're kidding. Personalities rock.
we're totally
I
Personalities.
kidding.
love personality.
Although there are some that are shallow and may look for that because they're shallow.
Period.
T.
All right.
And then the other intersex is like where they battle for like, they compete with other of the same like sex or
Yeah.
Yeah,
I
like the
just
males
said-
with the lines.
Yeah, like Lion King.
Yep.
So you know, mine, isn't it like they prefer,
I mean Hamlet.
they prefer with like they have like a big like mane. They prefer.
Yeah, stuff like
Yeah.
that.
Yeah.
And like whoever can protect their children.
Exactly.
Okay.
All right. I'm gonna go into pre-zygotic. The differences between pre-zygotic and post-zygotic.
That's when isn't that when like, it tries to like prevent like interspecies?
Well, you have to go through the pre-zygotic and the post-zygotic.
Yes, but isn't that like to
Yes.
prevent, like hybrids for like
Yeah.
Yeah.
Um,
Well, pre doesn't even allow it to
Two
occur.
different
However,
animals.
post does.
yes.
All right.
Yeah.
So within pre-zygotic, you'll see that it prevents mating and fertilization between different species. And causes of this can be habit isolation, where the population lives in different habits, and they're not able to meet habitats and different habits and different habitats. I'm sorry, and don't even meet. You can also see this between temporal behavior, where the mating and fertilization occurs at different seasons or times of the day, thus not allowing and preventing mating and fertilization from occurring. You can also see this in mechanical isolation, where structural differences prevent fertilization between the organisms, and gametic isolation, where the female and male gametes
Just don't work.
yeah, they just cannot unite, and fertilization and don't allow for species to be created through fertilization and mating. However, and then with post-zygotic,
I might be legit.
Oh.
sorry, post-zygotic is when interspecies mating actually does occur, and results in hybrid zygotes. All right, and so you can see this with lower hybrid viability or reduced hybrid viability, which is where zygotes fail to develop or fail to reach sexual maturity, and you'll see the opposite of this because it's reducing. And this is exactly what you would see, because it actually allows for the mating to occur,
Like,
as well as reduce hybrid fertility.
that's like for the mules and stuff, the fertility one, because they can like live, but they can't like
Produce like
breed.
functioning gametes, yeah. And then also you can see this with post-zygotic with hybrid breakdown, where the hybrids are sterile.
It's where like the hybrids turn into like the polar bear and the bear.
They go back into.
They
their
go back
original-
into their originals instead of like
Sterile.
instead of staying as like hybrids because they
of
aren't
genetic-
sterile.
Because of genetic differentiation.
They're not
Yeah,
sterile.
because of genetic differentiation, they start to go back into their original species. You missed the day when she talked about this, so you're fine. Yeah, we're at a competition.
It's
Yeah.
basically,
Yeah.
like the brother
I was
bear,
at a competition,
they're
I'm
fertile and
sorry.
everything, but the fact is that
I went over my
because-
notes and I really did try on that.
Well, because there isn't enough like roller bears, there isn't enough genetic variation, variability to make anything. So instead of becoming its own species, it either goes back into being a
Polar bear.
A
Polar
polar
bear
bear
or
or-
grizzly.
a grizzly bear.
No one wanted to tell me this before.
And
Go. And then it's Adam's.
All right, I'm gonna hand it back over to Adam.
Adam.
Oh, it's the.
23.
well, actually, if Adam doesn't mind, I want to talk about the what's it called? The Hardy-Weinberg equation or equilibrium. Basically, this equilibrium. You can leave it here if you want, or just hold it, like on the tissues.
Okay.
Well, basically, Hardy-Weinberg equilibrium means that it shows if it qualifies for all 5 steps, it is possible for evolution, right?
Oh, yeah, it was like-
for natural
For natural
selection of like a heritable trait
for an inheritable trait, and
or like the
basically
start of it.
for the start of okay. So there potential. Many words can describe it, but this basically falls into 5 steps that the population needs to pass for it to go, like equilibrium, like to be equal, I guess. And then one of them is no mutation, which basically means okay. It keeps like a consistent amount of like traits that are well, basically that's what it is. It keeps a constant amount of like good traits, I guess, and it doesn't have. It's not vulnerable to become like very easily mutated, which means that it's not. It's I don't know how to explain this. Okay.
It'll be permanent in a way, whereas like if it was like easily mutated, then it would be less permeable, so it would be like harder to keep within the genetic diversity of any of them.
Yes. Well, and then the second one is random mating, which you could use humans as an example because humans are able to like
Choose their mate.
instead of like, for example, how Riley was talking about earlier, like the peacocks. The peacocks like choose their mates from like a specific trait, and that prevents it from being. I don't know how that does. Hold up.
Yeah, humans are just more complex.
And it
organisms.
prevents inbreeding.
Yeah.
Yeah.
Yes. Number 3 is no natural selection. Which basically means there isn't anything threatening the species. Which another example would be humans, because we have no natural predator that like actually attacks us or anything.
We're at the top of the food chain, so
Yes.
we hurt other species.
And we're in a big house.
We in big house.
Yes.
They out there.
And like
Literally and metaphorically.
yes, and this is where most animals, most animals do not like fall in the list because most animals do technically have an upper predator after them.
Yeah, that's the only way, like, the what am I trying to say? Ecosystem could stay stable.
Yeah.
If there was no natural predator, stuff like overshoot starts happening where the a good example of this I think is like the white-tailed deer. I don't know if you guys remember this.
Yes.
In
Yeah.
okay. In apes, we talked about how like there's a natural carrying capacity. So on the graph, it's like a straight line, and gradually populations grow, but they're supposed to start. Yeah, excuse me. Exponentially. They're supposed to start leveling out towards that point, the K or carrying capacity point. But there was some cases, such as those of the white-tailed deer, where there was like that amount of hunters, how much hunters could hunt
Because there's
decreased. Yeah, because there was
a shortage
of deer. So decreased. So what happened was they didn't have any natural predators in the area. So
instead of like it kind of backfired on them.
Yeah.
And instead of like
Controlling the population, it went overboard.
yeah,
yes.
exactly.
And now there is like an abundance of like white-tailed
There
deer.
were so many that they were like
Destroying
running.
the
Yeah, they're destroying the ecosystem. They were becoming a burden on the other animals that were present in the habitat they were living in, and they were also becoming a really large problem for like humans living in the area. They would hit these deer as they would like run across the road.
The fourth one would be extremely large population size. And this again would also fall against humans because of course we have a huge population size which is more likely to like make more alleles be like allele traits to be like alleles to like different traits to be present. And then the fifth one was no gene flow, which means they're moving alleles out of the population, which can alter frequency, which means that we have more variations. So, like from where we live, like here in Texas, I'm pretty sure they have distinctive traits from if you say like Australia, because, well, yeah.
I mean, you can even use it as a comparison to like how we speak.
Yeah, it's kind of like accent, if you will. How one place could have a specific sound, like Texas is usually known for its southern accent, and if you look somewhere else like northern in like America, somewhere north in America, they tend to have like no accent. Or if you look at like Bronx, they have like a Brooklyn accent.
In Brooklyn, there.
Brooklyn accent.
I
In
thought
the
it was
Bronx,
Bronx.
they have a Bronx accent.
Yes. Well, that's basically it for the Hardy-Weinberg equilibrium.
No, there's one more, and that's no gene flow.
Oh.
Well,
Yes.
I guess
So bad.
It's
fine.
It's okay.
It's fine. You go ahead though.
I mean, I guess this would only occur if. I mean, I guess. I don't know. I'm trying to like bring it back to like how humans choose their mates, so like random mating is taken out of the picture. But I guess if there were to be no gene flow, then there would be, you know, just like no mating, and then the genes can pass on.
They'd be stagnant. So it would take
Yeah.
And then we'd all be white.
And
That's
then
so
we'd be
scary.
like,
We'd all be American.
That would be so scary.
That would be unseasoned.
we'd all be European.
Bland.
I wouldn't
And the
like
food would be
anyone.
bad.
Okay.
I would only
Thank you,
like
Miss
And that is-
Gaston.
thank
We're
you,
so
Miss
sorry I
Gaston.
got on a tangent. Bye.